Hi guys. Like you said, my name is Zach. I am the head of engineering at Telltale Games, and I've been there about 5 years, mostly doing various engineering and working on the engine and automation and things like that. So I'm here to talk to you guys about multi-platform asset kind of preparation, automation, and how exciting that can be. When you're like Telltale and you make games that run on a lot of platforms, this is a huge part of your life. So I'm going to kind of tell you what we do at Telltale, and you can admire my wonderful clip art that I made myself. Okay. So let me start a little bit about Telltale in case you guys aren't familiar with what we do. So Telltale makes games like this. This is a Walking Dead game we made a little while ago. Basically, we make episodic narrative content. So that means we're going to make a game that's about 2 hours long that people are going to, get 5 of these serialized over the course of a month, 6 weeks, something like that. And in addition to that, we try to run on every platform we possibly can. So, we're basically going to run anywhere that the game is going to run. And as opposed to kind of a companion app or anything, we generally try to sell the exact same content on every single platform. So, being able to do that kind of presents a lot of challenges in terms of build and automation. This is basically what we try to do. We humans, we make our wonderful games, and then we get them to mobiles, desktops, and really fancy consoles. The actual numbers of what that means, for a typical year in Telltale, we are generally going to try to do about 3 seasons that have 5 episodes, run them on 8 platforms, and typically you have 13 SKUs that you use for that between European versions, Steam, we sell it through our own site, is basically what we're going to be building every year. This generally, with a bunch of math, equates to about 180 shipped builds a year that we actually submit to partners, at least 120 different asset packages for these, and generally at least 9,000 builds are going to be done every single year. And this is probably on the low end of the number. This is not counting any of the patches and any other kind of things you don't expect that comes up during the year. It's probably well over this number. And to support this, we typically have about 2 build engineers, and recently we've been building out producers dedicated to it and things like that. But in general, most of the heavy lifting for this, we rely on our technology. So obviously, this is really challenging to do. Some of the big things that you're going to find when you're trying to hit the same content running on every single platform is, every platform is going to have a unique resolution. And when you're trying to get, a certain style or look across, what you're really talking about is what is the pixel density on over those platforms. If you've got 640, pixel tall screen, that's not going to need the same content that you're going to run on a 4K screen. Depending on if the character's face is, distance from the camera, you're only going to see 8 pixels on that face depending on it, and therefore it's not going to need the same texture, mesh resolution, and things like that. Also, obviously, all of the different platforms between PS4 and low-end Android and iOS devices have substantially different GPU and CPU capabilities, and many times they are optimized in very different ways. That, on some platforms like mobile, I/O is really easy because they got fast SSDs, but on, something with a really high-end GPU, I/O is a challenge because you're pulling it off of essentially a, 5,400 RPM disk. Another important thing to optimize when you're going across so many platforms and to not kind of forget about is your game download footprint. If you look at the quality of devices versus how much actual hard drive space they go up, those curves do not always go at the same rate. So this means that, certainly a lot of the mobile phones are capable of packing in really, really high-end textures that are going to look really awesome and run great, but you really don't want users downloading, a terabyte every episode if you're going to have 5 episodes, because you're really easily through 5 terabytes on their phone, and my phone has about 480 megs free at this moment, so I wouldn't be able to play any of my games. Additionally, with mobile, obviously, as a lot of people are experiencing, lots of different hardware targets. And with the exact same build is usually what you have to do on mobile. Unlike some of the others, when you're going across the different console generations, you don't have to worry about this, but certainly with mobile, you're going to have to. The other challenge that we have when we're trying to deal with this is just the sheer scale of it. We have about 20,000 assets go into every single episode of a Telltale game, which really means we're building about 180 million assets are going to be built by our server farm every single year. And these are really conservative numbers from our estimates. Episodes could easily have a little bit more depending on the complexity of it. So I think, I don't know how many of you have ever experienced this, but the common method I used a lot of times was basically hand reduce and alter content per platform. This is something that I think, if you've got a lot of effort and you can handcraft something for a PlayStation or for a PC, it's gonna be a common way to go about it. However, obviously, this is really difficult when you're trying to get identical experiences across on every single thing. If you're saying you want to have a really particular experience on an episode, and you have a director that's really passionate about that, he's going to care a lot about having, the trees in the background that are shaking in a certain way, trying to kind of, from a technical perspective or, arbitrarily reduce things to make the platform run better really hurts your ability to make, content that's going to feel a certain way or look a certain way or things like that. So it never is going to work. Obviously, it's very time intensive for art. That's the easy one. You're going to spend a lot of time. That's kind of the profit part of the fun and profit. If you can get automation to handle this, you're obviously going to spend less time for your artists having to spend handcrafting custom assets. It doesn't scale well. If you are going to rely on solutions that require humans to interact with things, you'll really quickly figure out when you have to do more content that it's never going to scale appropriately for what you're trying to do. Humans are terrible at scaling. We can't hire enough people, and you got to manage them, and it's all bad. So with machines, super easy to scale. Another really one that I think is worth mentioning, just because this is something that I've experienced quite a bit when we are unable to actually automatically get something to run, and you have to actually go back to art and say, can we change a scene? Can we reduce something? Can we take out these background characters that are too expensive? That system is exceedingly difficult to judge if you're actually doing something that's going to be effective. When you look at GPU profiling or CPU profiling, or when you're trying to estimate what the problem is, oftentimes that is very tough to then have the conversation with art about what they can reduce in an intelligent way for the game, and then you have to get the art done, re-export it, get it through your game, get it placed, remake the builds, test that out on device. All of that is going to take time, and you might have, during that time, completely shifted where the thing that was slowing you down is. So it's, again, just very difficult to do. Oops. I go back. There we go. So what does Telltale do about it? I hope we get it fixed, typically. But we don't really have any magic build organization software. Jenkins, BuildBot, Batch, Ant, Bamboo, TeamCity, all of this is kind of irrelevant to what I'm talking about. These are great pieces of software. We use several of these. And I definitely, if you're going to have a lot of automation, you need something to control it, scale across multiple machines. But in general, I don't think these are the interesting parts of what kind of gets you the power for running on multiple platforms. Really, the most important thing is you just need to pick something that your build engineers know how to use, because they're going to be debugging it. So when it goes wrong, these are the people you're going to need. So forcing one of those down to get automation is not going to help you. Just pick the thing that you guys are going to actually be able to use. Like I said, this is not where your time is going to be spent, is on off-the-shelf software. Though you do need off-the-shelf software, or you need to build your own, because you're going to need to get vision into when your automation breaks. The real thing that that we do, and that I think is important for this effort, is asset definitions and preparation. So making sure that you know what you're capable of adjusting for every asset, and making sure you can prepare it. And I'll dig into a little bit more about how we do that to solve this problem. So the very first thing we do is we have a pretty complex system for specifying what are things we can tune for every asset type. So really obvious ones are obviously like, if you have a texture, you can reduce its size. That's a parameter. You can reduce it by 50%. You can reduce it within parameters to say go no less than 256 by 256. You can say reduce it with a particular algorithm. There's parameters you can do to do that. There's different audio compression levels you can do. There's software you can do to reduce polygon size. There's level of detail software. There's a bunch of different things you can do to kind of categorize how your assets want to go. And so this is something that for every asset type in our engine, we have a series of tools hooked up and parameters that feed those tools that tell us kind of what we're capable of doing. And that's an important, obviously, an important component. The second part around that that turns out to be even more complicated is kind of organization and priority around all of those different parameters. So this is kind of for an asset like a face, you want it to be a really high resolution asset. You have assets that are background characters, you might want them to be really low-end assets. Kind of whatever it is, you're going to need ways to prioritize it. You're going to need ways for people to alter it. You're going to need ways to categorize it. When you're talking about 20,000 assets, this organization gets pretty intense. And it's going to change episode to episode, game to game sometimes, depending on, your art style is all very different. For instance, the Wolf Among Us game we did, substantially different way you're going to reduce your texture in that than you would in, the Game of Thrones or the Borderlands series, because just, the art style compresses in different ways. And then the last piece that we have in this mix, in addition to organizing it and then throwing it into the actual parameters that do the work, is the tuning tools that humans do to interact on this process. So at some level, you could say, all of my textures for this game get cut in 50%. And then you're going to send it to QA, and they're going to have it, and they're going to play through it, and they're going to be like, half this game looks bad. Here's the textures that don't look good. Here's, you're going to have stuff that isn't working, and you can generate lists of it. You can go through it. But that's going to waste a lot of time, and you're going to have a lot of people that don't spend their time, looking for the really good art, trying to make the decisions on that. So this is where the part that I think is important is you need to have tools up front while you're deciding what to do that allow you ideally dynamically to decide where assets are going to go and what they're going to look like on the target device. So we can have tools that live in our engine as the content creators be doing anything can, for instance, scroll wheel down through, resolution sizes, can automatically, compress the voice on the fly to determine what it's going to sound like when you go out, so that when we can take all of this kind of wonderful automation and technology that keeps to compress things and gets it down, but without some ability to really effectively and quickly choose what you do and don't want to tag, it'll get out of control really easily. And for us, because it is really an artistic thing, the best tool you can have is something that is in your engine, and you're kind of just dragging and clicking and touching objects in there to tag them. And so that's the last piece of the tech that we use to kind of get this done. Also, just as an aside, obviously, when you're talking huge amounts of assets, heavy use of caching those assets so that there's a giant system to make sure that if you have a certain asset that hasn't been touched at a certain size, that it gets compressed at a certain level. This came up for us when we integrated Simplygon last year, which was something we did. And within about a week and a half of integrating it, they gave us a call and they asked us if something was broken, because in the week or two that we had been using it, I think we had used it 1,000 times more than they'd ever had it accessed, because we just started running it on every single asset, and the caching was a little broken, and it was just constantly running overnight on all of our games, and literally millions of calls to their system to get it done. So really important that you're not doing that unless you want to burn out your computers and CPUs and everything building these assets all over. Plus, with this many assets and this many parameters, some of these take some time. So obviously, you don't want to have builds taking hours. Ideally, depending on how fast your teams work, the builds can be 10, 15 minutes if you're just changing what's needed. That can get very complicated, though, of course, with dependent assets. So I touch a scene that has a texture, and so you need systems in there to do that. This is basically what this looks like for us, is that we have basically people that go in and decide kind of what the texture tuning is going to look like, basically make specifications off of the default parameters for all the different asset types. And it's really not a lot of people. It's maybe one person, two, depending on the timing of the project, who's going to kind of make those decisions. Somebody kind of, if you can get people that are comboed of good with quality assurance and art, that's good people to tune. We have obviously a bunch of humans making Game of Thrones and putting the game data and getting it in there. And every night that's going to go into our big server farm that's, I think, about 16 machines that just takes all this data and just processes it every night. It's not particularly super intelligent server farm shared across multiple machines or anything like that. It's if you've done caching correctly and your tools aren't crazy. It's not like baking out lighting or anything. It takes less time than that. So we're typically able to just do it on single machines and it works fine. Anyway, that gets us out builds. So this may sound really interesting to you guys. I don't know. Where could you start? Because obviously there's a lot of time. Like this system has been in place for probably 8 years in some respect, and I've worked on it a lot in the last 5 years, and it takes a lot of time to get going. And if you're like us, build is also a really crazy, hectic. You're always getting stuff out, so you don't really have as much time to dedicate toward future automation as you would to the problems at hand. Any amount you do of this helps. Really, like even if all you're doing is have a way to visualize some of your assets and be able to play the game on the different platforms up front and know what they're going to look like, that's going to make huge benefits because the amount of time people spend custom crafting it is extensive. So it's worth dedicating the time to do. Visually and dynamically, adjusting parameters would be the thing I would say is really good to start with, especially because most engines already have this. You're already looking at assets. You're already looking at them. So just what you really want to do is look at them as they're eventually going to be when optimized for a platform. One note, too, I'd say is that the organization can be complex. So I would start very simply with this. Like we don't use something crazy complicated. We just have flat file system and star underscore facial character foo underscore star dot ANM, and then be like, okay, great. All of those assets get processed in this way. And that's it's not super elegant. There isn't a cool visual tool that drags and drop things, but as long as you've got some tools to look at it, it's pretty easy for people to do there. So, we've had systems in the past where I've looked on them where, you try to solve too much up front, and this is a good area not to do that because I think you'll have to debug it later. The other thing I would say is that if you want to try to do it, make sure you're not spending your time and spending the weeks it takes to tune something something that's not going to impact your games. For us, every game is a little different, but we didn't do mesh tuning for a long time because that was never an impact on the game. Like you want to look at your bottlenecks and be like, oh yeah, this is where all of the game is spending time. Let me give myself an ability to tune that. Or another way to think about it is, this is the area people are usually going over budget. We're usually going, it's hard to predict how many effects are going to go into a game because they could be heavy or light. So that would mean that's a really good place you should start by giving yourself as much leeway as you can to tune that on the backside if you know that's an area that you're going to have a lot of problems with. You don't need to spend your time tuning stuff that isn't going to make a big difference on the target result, or is something that's going to be consistent no matter what. So it's not something you're going to ever have an effect on. That's kind of the main thing. I mean, many of them will affect it's complex, so you kind of have to work with engineering on it. When you have less animations, it might take less memory, less CPU hit. It does get to be each thing you decide to alter can change in big ways. So you usually get a bunch of wins by doing a few things. So I wanted to run through one quick example because I think it'll show you guys what I mean by once you've got kind of the baseline of this established, that it isn't really that hard to extend it and make really big important impacts to your studio if you can commit to this and really make it so you can go to new platforms much easier, and it's not a big mission to get to add another set of mobile devices that you didn't previously support before with just a couple of weeks of engineering and some automation could make a huge difference in selling to those phones or to hitting the PS3 if you're on the PS4 or whatever it is that you want to be doing. So when we did Game of Thrones, which this is a picture of, it was definitely the highest geometry game that we had done before. Most of the scenes like this one was particularly complex in the amount of just geo going on. And so the cost of that ended up being much higher than we were kind of expecting. That was not something that, just as the episodes come together, we realized that, you're going to have crowds, you're going to have fights, you're going to have areas that just need a lot of geometry in them in order to be effective. The intro scene in particular, running through the the wedding, was just a lot more than we'd done. So, and we didn't have a lot of tools to alter that. You can reduce all of the texture costs associated with these things and make it a little blurrier, or you can reduce animations a little, but none of that is going to impact if there's just too much geo to draw. So one thing we did was we integrated Simplygon to the pipeline, like I had mentioned earlier, to tune existing asset categories for our current games. We did this over about a 2-week period. It was kind of shockingly quick. All we really had to do to get that working was, they have a system, if you guys haven't used it, where you can kind of throw a mesh at it, and it will kind of do its best chance to reduce it to a mesh that looks just about like that within a certain error percentage. And you can specify the error percentage, and you can tag areas you don't want reduced as much, and things like that. So basically, we hooked that up to our system where, again, we already had our mesh format. We already had the tuning system doing some alteration work to get it into the final mesh format. And so we just kind of hooked that into the middle. So we would have a new tuning parameter that was, error percentage, or we just kind of called it, there's like a magic number for it. And basically just kind of hooked that into it so that our internal mesh format, before going into getting packaged for the engine, would run through this Simplygon process. And Simplygon is something you can use on the art side as well, but we wanted to do it in an automatic way so that nobody had to kind of think about what it looked like. The real key, of course, was we already had existing tuning tools that allowed us to go through and tag, textures as, we don't want this texture to be at this quality. This texture is a face. We already had a bunch of stuff that determined that characters need to look better than, the ground and things like that. So we hooked those same things up to say that, if your texture is touching a mesh, the edges that's touching should be higher quality because that texture is a really high quality. And so as a way that really over just a couple of weeks before the project shipped, we were able to integrate this into our system, apply the automatic tuning, and really, probably saved, 5 to 10% of our frame back that we were spending on GPU. It basically pushed the bottleneck out of there without having very much visual impact on the game, because we could apply it holistically and then go through and actually tune it to what it should be. Drink. There we go. So in this scene in particular, after it's been tuned, it had definitely things where, these should be more curved, and there's some stuff like that. But, stuff like the characters and his edges and things like that can still maintain at the higher quality because characters could be tuned to be high, could be tagged to be higher, and the rest of it could be less. So some future work that we have in this area. So definitely the part of this that I've personally been spending a lot of time working on and I think is really interesting is that, tuning parameters, the area where we have humans go through and kind of decide what looks right, what doesn't look right. I still believe we could probably get something fairly automated to do that. At least in Telltale games, I think that's very possible, and probably in a lot of games you guys work on it is. Telltale games are very, camera predictable. Like we know most of the time, except for free walks, where the player is going to be at all times, how far a background is going to be for you. This is all things that we know. So developing ways that can automatically play through the game and determine that, certain textures are only going to ever be between 15 and 40 units from the camera at any given time, and then be able to take that and then calculate, well, that means on a target output device that's 480p, you can calculate that to hit those two, it should never get smaller than 128 by 128, and try to most aggressively do that based on what the texture is. So it's not something we have right now, but it's something where we're kind of piecing bits of that together to basically give a first hint toward the tuning to try to match as close as it can to the actual target platform. And I think that's going to open up a world of really fun things for us because our games are very, because they can, you can play through them and know all of the different paths, that will be able to make a lot of really fun decisions on handcrafting the assets for certain platforms based on our knowledge of kind of nightly running through the game over and over again. You can imagine having non-deterministic, animation compression that, the animation compression looks really bad if you looked at it close up, but in reality, the camera is such that you only see the back half or you only see part of it, and so the compression can take that into consideration when it's compressing it and not compress the areas that people are going to see. And I think that's something we're really close to doing if I can kind of get the support and kind of build it. I want to, we have a lot of data mining platforms we use for our current games out in the wild, where we know how users are making choices, and we aggregate those, and there's kind of a whole field that dives into this. I'm really kind of enamored that we could use this for build engineering, so that while QA is playing, we can automatically be detecting the scenes that are having the low frame rates, what's on scene, when that is there, and be able to drive those toward where we need to look at more aggressively sooner, because we know those things are happening. I mean, all of this is kind of feeding that, like, the development team is off building in our tools, and we have a whole separate set of systems that kind of nightly are trying to adapt the actual output content to what they're building on the fly. And I think this is a way we could pretty easily do some of that. Ultimately, one of the things about this, as I mentioned, is giving greater latitude for artists. That, our tools, if we can do all of this stuff really effectively, what this means is I can tell them, just make the game in this beautiful tool, make it in the way you love it, make it what you think is awesome, and we will make sure that nobody notices the difference between that and something else based on the capabilities we have on the platform, and they can kind of be freer to build better assets, bigger assets, make it look really nice, and not have to worry about what it's going to look like on this PlayStation and things like, or whatever console, what it's going to look like. They can just make something awesome, and that's a lot of where all of our technology at Telltale resolves around that. But in particular, this is one area where I think it's been pretty effective. I'd like to also extend it to new systems. Effects is one that I think we could use it on. So. Kind of sum up here, because I think we're running out. Multi-platform episode development is hard. Takes a lot of time, a lot of builds, lots of fun stuff going on there. Takes a real deep dive into some of the tuning and automation, but it can make a huge impact if you're willing to take that dive. I think it really can save just an incredible amount of time and really allow you to reduce the all-important time between content is done and your shipping can be less and less if you can get this to be automated. A good system can start small and expand. As we've done in the past, we've expanded a lot over the time. And also, there's just lots more to do. We have lots more stuff. So, cool. I think that's my presentation. Is there time for questions, or are we? Well, cool.
So we're starting to build our game on PC, and we're not sure what platforms we'll be going to. What are like the absolute minimum steps that we need to be careful of if you want to start building these kind of systems? What's the baseline?
I would say if you're unsure if you want to go there eventually, but you want to have your assets, kind of as ready as you can. I think like I said, make sure that you're going to be able to preview them in those resolutions at the very least. Like that's like the easy really start thing, right? Like a PC already has variable resolutions. So like in our tools, we have a little drop down that says, make this look like an Xbox, make this look like a PS3. And all it does is turn on the right level of rendering for that platform, which might be turning off some After Effects or some other features, sets the resolution to be like that. Even that small step allows you in a very kind of a way to start looking at what it's going to be like. And then you can start integrating other parts of that in and being like, oh, okay, now I want to start preparing assets for what they're going to be on that platform in an automatic way, and then look at those there.
Have you guys thought about like VR, like doing games?
Who isn't thinking about VR?
Okay.
VR is awesome. Yeah. I have no idea. VR is super cool, though. I personally like it. It seems neat. Possibly. I mean, it depends on the target platform. I think that's like mobile, where there isn't one platform. So I think as platforms get established, we add new platforms a lot. We added PS4 and Xbox One last year. That was a pretty easy switch for us because it was just a higher end version of some of the stuff we'd done already. But as we get new platforms, they all drop in pretty easily. They're a new bucket of platforms, a new set of tuning parameters, and you kind of set it up and go. So if there's a VR platform that exists and that's something that we do, then it'll just be another platform to drop in. So version control, I've used many things over the years. We use Mercurial for assets. We use Plastic for raw assets. I've used Perforce in certain areas. Like I think it's kind of like the build bot and that stuff. It's all kind of, as long as nothing's broken and it's fast, it's somewhat irrelevant to the hard stuff. Like it should be stable, it should be fast, it should be something your people know how to use. That's probably the most important. But most of the time that gets integrated into our tools anyway. So people are kind of working in the tools. I think those all just whatever works for you. Cool. Well, thank you guys. It was fun.